Hello everybody and welcome to this talk from Davide Benedetti from the Polytechnic Institute of Grenoble. Davide is going to present on the rapid prototyping of 3D electronics using direct ink, writing and 6-axis robots. As always, we will be taking your questions after this presentation, so do please leave them in chat and I will come back at the end and take your questions. Over to you, David.
Okay, thank you, Chris. Hello, everybody. So I will present quite shortly our work on the use of 6-axis robot to print electronic path on 3D generic object. So the main structure of our representation is quite simple. So just to introduce why we decide to use 6-axis robot to 3D print on generic object. Shortly describe the experimental setup, how we manage the generation of the trajectory and the speed analysis. I'll give you some examples of circuits that we printed on a simple model dome. And finally, I will give you the conclusion. So why 6-axis robot? So we started working on this subject almost 5 years ago. So at the time, there were just already many other techniques to develop 3D electronics, such as laser direct structuring, full 3D printing object, both the circuit and the object, two-shot molding, so thermoplastic molding with embedding PCB inside, or even aerosol spray with 5-axis devices. Anyway, our objective was to search for a simple method which could be easily scaled up to print 3D circuits on generic object. And when I mean generic objects, it means that pre-existing objects, which can be thermoplastics, composites. In our lab, we work on paper, so our objective at the time was to use molded paper, three-dimensional paper as a substrate, concrete, and even wood. So naturally, we selected 6-axis robot just because they can be really easily scaled up. We can find every supplier as different robots with different size, from very small robots with a reach of 0.5 meters to very large robots of 3 meter reach, which can keep a quite good repeatability in the positioning of the robot head, which is about 20 microns for small robots, up to 100 microns for large robots, which remains a quite good repeatability. Other aspects which are positive, which motivated us to select 6-axis robot, are the speed of these robots, which can be very fast, the repeatability, the availability of these robots in modern industry, which are already available. They can be adapted to work in harsh environments, and the technology can be very modular. On the other hand, there can be some drawbacks, just because it can be quite difficult to adjust precisely the speed and the position of the robot at the same time. Second critical aspect can be the offline programming, because there aren't ready-to-use commercial software which can be immediately used to design and print 3D circuits, and the machine setup. I mean, to our knowledge, today we don't have commercial robotic printers which are available on the market. So our first idea was to have a quite simple approach. I think that everybody working on the robot has this idea. So take one object, generic object, which can be, this is an example of fuel tank. We put the object in the working area of the robot. We scan, we have an idea of the shape. We reposition the object in the working area of the robot. So we design the circuit, we print, and then we send the object to the next processing stage, which can be pick and place in curing and other processing. So what we did is that we build up, is on the left, a robotic bench with 2 robots. We just use, in this case, the first robot, which is equipped with a laser scanner and a print head. Then we make the scan. We make a blank run to recovery. After we generate the trajectory, we make a blank run to recover all the speed and the position of the robot using the sensors which are on the robot. Then we generate the code and we synchronize the jetting frequency of our print head. We use a piezo jetting print head. We print, and then we reuse the scan with a